All right, welcome back to 423 Moving with Color. We are going to move on to steps 24 on. It starts off with highlighting that these colors have a range of values. And so the optical sensor can report colors as numeric values. And it reports colors in degrees from 0 to 360, where red has a range from 0 degrees plus or minus 30 degrees, so from negative 30 to positive 30. Yellow has a range from 60 degrees plus or minus 30, so from 30 all the way up to 90. And then green from 120 degrees plus or minus 30 degrees, so from 90 all the way up to 150, and so on. Okay. So I am going to use the range of values here in degrees instead of what I had been doing, which is if color blue. And so I have a feeling that if I get outside of a range of red, maybe this won't work anymore. But if I give the range from negative 30 to 30, it will detect red. That's my guess, but not 100% sure. There's another way to program essentially the same thing. So we're going to use this if statement instead of the if statement here, where if optical 2 is red, it's asking the question, is my color red? This is asking the question, is my hue between negative 30 and positive 30? So is it greater than negative 30 and less than 30? And so that'll give it my range. And so I'm going to replace this line of code that I have highlighted here with this line of code instead. So I'm going to go ahead and delete this here. Actually, I'm going to go ahead and copy this over. Can't forget to copy the LED light turning on my optical sensor. So I'm going to replace this line of code here with this line of code here. So I'm going to go to sensing optical hue. So if optical hue is greater than negative 30 and optical hue is less than 30. So that's going to give me my range for that for hue. Now, a couple differences you might notice is this one says optical 1, mine says optical 2. Why is that? Well, if I go back to my sensor setup, I placed my optical sensor in port number 2, whereas in the instructions of the activity, they placed it in number 1. I have a smart motor in number 1, and so I couldn't use number 1. So smart, slight modification there. I'm going to do the same thing for blue to detect that color. And so instead of using this line of code here, I'm going to say if optical hue is greater than, and let me look at my blue range, it's 240 plus or minus 30. So that'd be 210. And optical hue is less than 30 degrees above 240, which would be 270. If that is true, then print blue on my screen. Okay. Now, as I scroll down, it says replace the condition in your if statements to use a hue instruction. Select download and test your program. So I'm going to go ahead and download this to ensure that it still works the way it did before. Let me go ahead and display my iPad again. Oh, I am recording. Okay, I thought I wasn't recording. All right, so I've downloaded it. I'm going to go ahead and run it. Am I displaying my iPad on my screen? I'm not. There we go. So I'm going to go ahead and hit run. My LED light comes on. Blue, red, blue, red. Seems to be working just the same. Okay. So same program, programmed a different way. This one is using the hue range in degrees for these colors instead of just asking if it's red or asking if it's blue. Okay. So more options and a little bit more expandability there with the option to change that range. So that's actually pretty useful if you're trying to distinguish maybe between two different shades of red. Um, this one color red will distinguish all reds as red. This one here will distinguish between any red between -30 and +30. But if I have two shades of red that I'm trying to differentiate between, being able to play with these ranges might be useful. Okay, let's scroll down to step number, where was I? That was step 26. So what we're going to do now is we are going to write the names of the colors we're testing on a piece of paper. And I've already done that. You've probably seen it several times now. I've got my piece of paper here with red and blue documented on each of these. So what we're leaning into next is making the servo position itself to red or blue based on the color of my, in this case, my little cubes here. So not only am I going to print it on my screen, just like I had been doing, I'm going to give or require the servo to move to either position based on that. Okay. So, oops. Got an email. All right. So let's go ahead and try that out. So place the pointer mechanism on your piece of paper. I've already done that. Program the angle of the servo so that points to the name of the color detected by the optical sensor. When I was testing this out at the beginning, when we were playing with the servo, I determined that the blue, to point to this direction, that was a servo value of -45. And to point to the red position, that was at the midpoint. So I'm going to go ahead and borrow from the code that I had previously to expand the if statements to add those additional lines of code to position my servo in either direction. And so let me go ahead and go to my program. I'm going to go up to the very first part, which is parts 1 through 11. And so here is that line of code here. And so if my optical sensor is reading an object, check to see if it's blue or red, red. And if it's red, let's position to the midpoint. If it's blue, let's position to -45. And so I'm going to add that line of code here, -45. Now, the nice thing about what I did is I went ahead and added midpoint, the variable, and defined what that was above all of these sections of code. So now that I've commented out this, this is not commented out. So I can still use this variable called midpoint without having to redefine it. So I'm going to grab this line of code. And if it's red, I want the servo to position to the midpoint. I believe this will work. Let's go ahead and download it and try it out. And give it a go. So let's see. All right, so I'm just going to hold this here. We know that the display works just fine, so I'm not going to bother taking my camera and looking at that. I'm going to go ahead and just hit run. So I hit run on my computer screen using my cursor. I'm going to grab, my red block. Servo didn't move. Grab my blue block. Servo didn't move again. What's going on here? Well, let's think it through. Okay. So servo A set position midpoint degrees. And if it's blue, servo set position -45. So I am having issues with my servo. So let me go ahead and stop my program. I'm going to comment this section out. I'm going to go back to my first lines of code, test my servo again, which is parts 1 through 11. I'm going to see if my servo is working. So I'm going to download this. I'm going to run it. Seems to be working just fine. Okay, so my servo is operational. I was able to figure out, and it's something so easy. And it was, you know, something so easily overlooked. Here was my issue. I didn't comment out the previous section of code. So I was trying to run this, but I was stuck in this code still because this says while true. So I'm always stuck in this while loop. And so, you know, I got the behavior of this turning red, you know, the display of my LCD printing red and blue, red and blue. And so that was working. But I didn't see the servo positioning because I wasn't running this code. I was still running this code because I was stuck here because I got into this while loop and could not get to part 24 through 29 here in this bottom code. I overlooked the commenting out of that section of code. So that was a my bad. Something so simple, yet so derailing. But anyway, problem solved. Got to comment out the code you don't want to run. I don't want to run this anymore, so let's run this. So let's go ahead and download this now. Again, if I'm reading between -30 and 30, a hue between that range, it's red, and my servo should position itself to the midpoint, which is this direction here. So the arrow should point this way. If my optical hue is reading a range between 210 and 270, well, that's blue. And so the arrow should position itself back to the blue range here. So let's run this and take a look at what happens. So let's see. I'm going to put a blue. All right. On my screen up there, you can see it displays blue. And my servo position itself to blue. Take that off. Place a red cube on there. And now it's positioned itself to red. And I can go ahead and redo it as many times as I'd like. And I might just sit here all day and just do this because I was so confused as to why it wasn't working before. Got to comment out those sections of code. Okay. Oh, we got that done. It's going to happen to you. It's going to happen to your students. You know, they're gonna make simple mistakes that cause them to think for a good, you know, 5-10 minutes or beyond. But they can power through it, and then they probably won't make that mistake again. I can guarantee I won't make that mistake of forgetting to comment out an entire section of code. So this takes us all the way through step 29 of activity 423. And now we get into this on your own section. It says for the remaining steps of this activity, you'll program your device without the benefit of coding solutions. So up to this point, it said, check your code, check your code, check your code. Now it doesn't give us that at all. So we are going to go ahead and create a new section down here. I'm going to call it part 30 through, let's go 38. If I can edit that if I need to break that up. I'm not going to forget to comment out the previous section of code. So that's not going to be a mistake I make twice. But now it says, go ahead and connect the smart motor to port 6. Okay, well, sorry, I connected it to, well, I haven't connected it yet. Let's go ahead and connect it. And they want port 6. I've got it connected into port A right now, or port 1. So I'm just going to use port 1. Click done. So slight difference between the activity and what I'm doing. Instead of putting it in 6, I'm putting it in 1. It's just more accessible for the way I have it set up. Okay. In your program, configure the smart motor to port 6 and confirm it's configured correctly. Modify your program. So I'm going to copy what I have so far because we're going to add to it. It says modify your program to add code below each if statement to move the smart motor with, oh, I went too far ahead, excuse me. You have used optical sensors built in LEDs to brighten its viewing area for reliable sensing. You can add external LEDs to signify state changes in your device, like when the optical sensor recognizes a color. Connect 2 LEDs, any color, to the brain using 3-wire ports B and C. You'll need a 3-wire extension cable for each LED. Now, one of the things that you're going to want to do is if we take a look at my setup here, I've got these two LEDs connected to these extension cables, and I'm going to connect this blue one here, which is this cable here. I'm going to connect that to port B. And then I'm going to take this red LED, which is right here, and I'm going to plug that into port C. Let me get that in there. Okay. So I've got my red LED, I've got my blue LED. I can test to see if they're working. Let me stop my program here. I'm going to go ahead and go to devices. I'm going to go to my 3-wire options. I am going to, again, that's ports B and C. So I'm going to go to digital low. We'll turn it on. And so I'm going to go ahead and select digital low for the other one. Oops. There we go. And my LED, my red LED is also on. So I know those are working. So let me go ahead and turn those off. I'm going to control it with my program anyway. And head back. Okay. So here's what I want to do. If my red block is detected, position the servo, turn the red LED on. If my blue block is detected, position my servo, turn on my blue LED, and I'll still be displaying my colors on my display of my LCD screen. Okay, so it says in your program configure ports my LED. So I've configured my motor because I accidentally jumped ahead to step 34. Let me jump back and let me add a device. It's going to be a 3-wire. It's going to be an LED, and I put one in B. And I think I put, was it the blue one? I believe I put the blue one. I did. I put the blue one in B. So I'm going to call this LED blue. And I'm going to go ahead and add a device, 3-wire, LED, in port C, and I'm going to call this LED red. Okay. So I've got both of those now configured. I can exit out of that. And what I'm going to do is use LED on to light an LED when the optical sensor senses a color with hue, and LED off when turn both LEDs off at the end, at the start of the while loop to reset the LED indicators at every iteration. Okay, so I want to turn the LEDs on and off. So initially, when I start my program, I want my LEDs to be off. And so I'm going to look for my LEDs in my library here. I believe that might be under looks. It is. So LED off. So I'm going to add that at the beginning. Let me create a space for that. LED off. Okay. Now it asks me which LED do I want to turn off. And I've got two options. I got LED, I think underscore blue. Will it let me do that? Oh no, I don't have to. It's already given me LED blue off right here. Let me go ahead and do the next one. And so if I want my red one to be off, I can change this to red. There we go. Okay. Again, they don't guide you here. I guess you're supposed to just figure that out. So LED blue off, LED red off. If my optical sensor reads between this range, it's going to be red. So it's going to position my servo, and I want to turn on my red LED at this point. So I'm going to turn LED on. Oh, wow, created so much space. So not blue. I want my red one to turn on. And then I want to turn on my blue one if it detects blue. So LED blue. That time it went ahead and selected the right one. Again, if I want something else, I can edit this. So I take the same exact code, but I add LED red on, LED blue on. These names I defined when I set up my LEDs in my device manager here, LED blue, LED red. Okay. And then again, when it loops back, ooh, I put them in the wrong location. Every time it loops back, I want this to tell it to turn my LEDs off. Oh my gosh. Control copy. There we go. Okay. So it's going to loop back and tell my LEDs to turn off. So it only displays red or blue when I have an object in place. All right, I think I've got this set up. Let's go ahead and download it. Let's go ahead and go to my device here. So I'm going to open up my iPad. So you can see it here. I'm going to click run on my brain. Notice both of my LEDs are off. Now, how do I connect my LEDs? I think that's worth talking about before we move forward. So my LEDs are plugged into these extension cables. I could have used, again, a Vex LED, but I didn't like the brightness on it. So here's what I want to do. I want to show you. All right, so to connect the LED to the V5 brain, you want to use these extension cables. So the extension cables have 3 wires. Got a black wire, a red wire, and a white wire. And it's got the female side where you can plug things into, and the other side of this is the male side that goes to the V5 brain. Okay. So again, connect to ports A through H in the V5 brain. An LED has an anode side and a cathode side. So for the Vex LED, if you look really closely, you have these little flags on the inside of the LED. The big flag is the cathode side, the little flag is the anode side, and the same is true for a standard LED. The big flag is the cathode side, the little flag is the anode side. And so to properly connect LEDs to your V5 brain, you want to use the extension cable, and you want to plug the LED into the extension cable such that the anode goes to the red wire. And so each of these will lead to the little ports you can plug into. The anode side, the little flag, will plug into the red wire. The cathode side, which is the negative side, big flag, should plug into the white wire. And if you do that properly, the LED will work properly and it won't burn out or not work at all. Okay. So let's go ahead and go back to taking a look at this setup now. So I should have, again, my LED lights turn on depending on which color of block this is. And also the servo is going to position and my display will display the text red or blue. So let me download this. I forgot if I downloaded it or not. Oh, let me go ahead and delete these 2 lines of code. I don't need these. I only need to tell it to turn off at the beginning of the while loop. All right, let me run this. Nothing happens. I put blue, and look at that. Not only does my servo position to blue, my text up here says blue, my LED turns on, my blue LED. Remove that. My blue LED turns off. I position this, it is red. My LED turns on to show that it's red. And I went ahead and added a delay of a second here. When I was trying to troubleshoot and figure out what was going on, I started adding a delay. I don't really need that delay. Let me download this again. Let me run it. And it should clear my colors much more quickly. There we go. Working as intended. All right. Let me see. I think we missed. There we go. Red. You can see the blue light over there. You get the idea. All right. So let's go ahead and take a look at the next step. So this is really part 30 through 33. We are going to just continue expanding this code. So I'm going to just create another section for it. So that way we can differentiate between the sections of this activity. Let me paste that. So again, multiple line comments. Let's not forget that. All right, so for the last part of the activity, we now want to position a motor to those locations. So add code below each if statement to move the smart motor with the spin to position instruction. Experiment with the value so that the smart motor points to the color names in the same way as a servo motor. Add unique tones for your new feature. Select download and then start to test your program, iterating to get accurate results. Okay. So we're going to have to play with some values here. Let's go ahead and try this out. So first thing I'm going to do is I'm going to, I've already got my motor set up. I put it in port number 1. I'm going to go ahead and go to motion. And notice I now have all these motor options that I didn't have before. Previously, I only had the servo set position. But now that I've added a motor, I can go ahead and control my motor. So I'm going to use my spin to position, motor spin to position right here. Okay. So I am going to drag that right into here. And I'm also going to drag it down into this one. All right. Got all these extra lines of code here I don't need. They're empty lines. Add a little space. All right. All right. After playing with this for a bit, I found out what was happening. Essentially what happens is that the motor spin to position always starts from its new position that it left off at. So what we're going to have to do here to get this to work correctly each time is that we are going to have to, if I'm, going to run my program several times where I stop my program and then run it again, I need to set this motor to a home position so that way it works consistently each time. So let me demonstrate to you, why that is. So here we are going to, just like before, print red or blue on my screen, position my servo to either red or blue, depending on the color of my cubes, turn my LED or my blue LED on, depending on the color of the cubes. But then I'm also going to spin my motor to a position. So I've set this to be my home position, and I'm calling this my 0 degree position that's pointing to blue. And I'm going to rotate 45 degrees to get to the red position. Okay, so let me go ahead and run this to test it out. So I'm going to put my red block. It detects that it's red. My LED turns on. My servo positions. This positions to the right location, shows that it's red. I take it off. I put a blue. Does the same thing. Positions to blue. My blue LED turns on. Back to red. Back to red. Back to red. Nothing else happens until I go back to blue, and we're good to go there. But what happens if I end my program on red? So let me go ahead and stop this. My motor is pointing to red. So if I start my program again, well, guess what? That's the new 0 degree position, because if I put a red block again, it rotated even more. I put a blue block and it goes back to its home position, or to the 0 degree position. So to correct that, what you need to do is each time you run this program, at least using the smart motor, you're going to have to reposition this so that it ends in the right place each time, or starts in the right place each time. So what I'm going to do here is I'm going to make red my 0 degree, And I'm going to make blue now -45 to correct that error that just occurred. So let's see if we can fix this. All right, blue should go back the other way. That fixed that. Red went that way. That fixed that. Okay. All right, so just something to look out for with the smart motor. That spin to position is going to recall the last, or it's not going to recall what value this was. That's going to be its new home position, and all my degree measures are going to start from that position each time. So this concludes activity 423. I hope you enjoyed the videos, and I hope you're able to replicate and try some of these programs out on your own. Thank you. Have a great day.